Bayesians don't like this approach because it is functionally impossible to take an infinite number of experiments. You've always got to make some kind of assumption. And then Bayesians take the view that an estimate of that event A occurring should be based on past experience with A occurring. And to me, that makes a lot of sense. And then frequentists don't like that approach because it is not a purely objective approach based on what Shaw is saying.
Right.
Question 2.
So if you want to just hold on that for a minute,
sure.
Since you're up first, you kind of get you can toss the ball. So I want you to pick one of the other people in the room to ask them to discuss the graphic that we started with, which is, whoops, let me pull it up. So you get to kind of, right now, if you can kind of formulate a question and pick somebody with this as the inspiration. So if somebody's been playing with, trying to figure out what is frequentist, what is Bayesian, and you want to use humor to do it. So who do you want to ask to elaborate? And what kind of question would you ask them with this as the graphic as the inspiration?
So, Drew, I know you're also a fan of XKCD, so sorry. So now I need to come up with a question to ask him about this?
Uh-huh. And you can do a very open-ended question. Such like, Drew, can you elaborate on X, Y, and Z?
I guess basically, Drew, how would you say that the frequentist statistician cartoon and the Bayesian statistician cartoons reflect the information Shaw presents?
All right, let me give this a shot here. So I'm on my speakerphone, so hopefully you can hear me okay.
Yep, it's good.
Okay, so the frequentist, it looks like they're... So one thing that was interesting is when I went through and did the homework and you got to Bayes, so I know they like to talk about it being way different, but a lot of it seems to be there's some overlap between what they like to do and what they don't. But on this one, the frequentist seems to be pretty fine as far as what you're doing. That makes the frequentist look silly, really, as compared to what we've got in Shaw, because it starts bringing in the p-value tests, which if you read XKCD, you know how much he loves to poke at p-value tests, like his cartoon about the M&Ms causing cancer or whatever, where he tests 20 different ones and then the result is, one of them, like you'd expect, shows up that it causes cancer. So I think that's pretty fine. The Bayesian thing, I think people who like Bayes seem to really like Bayes, and think it answers a lot of trouble. As far as how it relates to the Shaw text and his joke, I'm not sure. Besides, I think if I was a Bayes guy, I would have bet a lot more than $50.
I guess it seems like the Bayes. Well, sorry, I won't. Sorry, never mind. I got nothing.
So that, I know that was kind of a vague answer to maybe a vague question. What else can I say?
I will have you know my question was extremely vague. And yeah, I mean, I'm kind of with you. It's like I think I'm probably more of a frequentist myself, just because I don't. To me, this cartoon says that Bayesian statistician is more interested in the big picture, and the frequentist statistician is more, I guess, detail oriented.
Yeah, but I mean, like if you're gonna do, but the Bayes still needs to be linked to numbers somehow too. They just jump from it being linked to numbers, and it's probably actually a pretty low probability, way less than the 1 in 36, right? Is that the chance actually the sun really exploded. But it's really a problem with the p test instead of a problem with the frequentist interpretation of statistics, I think.
So, right, and I guess that's kind of where I was. What are you doing with the fact that the neutrino detector is making a measurement, but then there's the roll of the dice?
Right, and this is similar to the homework we did, right, where you have your widget detector, and you only have a very small chance that the widgets are actually bad, and your widget detector isn't super great. So it turns out, like, even if you're saying, what's your probability if it shows up and it says it's good, that it's actually, like if it tests it bad, what's the probability that it's actually bad? And like in our homework, you see that, well, it's probably actually still good, just because your test sucks so bad. So that's kind of the part that they left out of the frequentist statistician part, right? He's just going like, well, it's the chance that it's line tooth is only like 1 in 36, and it's like, yeah, but you're not including what's the probability that the sun actually exploded, right? Which they just kind of cover over in the Bayes.
Right.
Yeah.
Yeah. And when all's said and done, if you were showing this to a person that you, of course, now y'all are at ORNL, so if I say a person on the sidewalk, your person on the sidewalk is going to be different than my person on the sidewalk. So the humor in a cartoon like this, I don't know. I'm going to stop. I guess I'm wondering, could I use this as a litmus or just a quick test to determine if somebody has a knowledge of the two interpretations or the two approaches to probability? Could I use someone's reaction to this comment, this comic, or get them to try to explain the humor in it as a measure? So if I put this in front of a bunch of undergraduates, like pre and post a series of learning exercises to try to figure out, probability, would this work? Could you ask someone to explain the humor? Just kind of like, I mean, you sat here and kind of had dialogue about it, right? Clay, Drew, right? So what is your thought about using it as a assessment tool to figure out, can we use humor to figure out, do engineers know anything? Versus taking it out on the street. I'm pretty sure if I showed this to a lot of people, and even in this building right now, I'm not sure how many engineers would laugh with me on this.
I think it can be good. It's kind of the equivalent, I think, of when you give somebody like, review this thing and tell me what's wrong with it, right? That seems to be the same sort of thing of like, let me, why is this joke funny, or what are they talking about in this joke? Why should I laugh? It makes you kind of think about, what's right and what's not exactly right because they're taking liberties to make a joke, and that sort of thing. So I think it could be a good test.
I think it's part of a larger diagnostic. But given some time to think, I think that you could come up with a good explanation for both, kind of an explanation of frequentists and Bayesians.
Yeah.
I don't know if you'd want to rely solely on this, especially if you're relying on engineers to have humor.
I know, well, that's the great thing. You're relying on engineers to kill the joke, in which case we probably should be able to pull that off.
Excellent.
Okay, good. Well, I'm gonna kind of take a different tactic this time. Instead of Clay, instead of having you walk us through all three of these, I'm gonna go to the next person.
That is perfectly fine by me. Thank you.
All right, Doug.
Can you hear me?
Yep.
All right. So Let's go with the first one because I was bored. So,
I like this one, by the way. Okay.
so this is the copper farthing, and basically it's the frequentist A, frequentist B, toss it a different number of times. And it goes back to the way I learned the difference between frequentist and Bayesian was actually in Vegas. I worked at the Nevada test site, not in the casino, but basically they're limited, and it's the same as Clay's first question, except it's hidden. So if you go back and ask a frequentist, they will give you an answer based off of what they've observed, not the total population.
Mm-hmm.
So you can actually give frequentists answers that they expect. We find this in a lot of codes that use statistics, especially when they are biased, that they want to produce an outcome. And that was that one. Yeah, probably cutting off. We're Y12.
Okay. So, Doug, let's see if you can do the same exercise. If we take your question and extend it, can you ask someone else in the room? It's your choice as to who to toss it to ask them something based off of your question, but maybe like an extension or something.
All right, so the extension question would be, if you have a frequentist that tosses a coin only one time and it comes up heads, what would Bayes say that frequentist will always answer the outcome is? And I'll ask Kevin since he's right next to me.
Yeah, they'd say it always come out ahead 100% of the time. Because that's all the data they have.
Did we cut out again?
No, we're listening. So the frequentist can only toss the coin once, but the frequentist does know that there's two sides to the coin.
Correct. But if you ask, but the Bayesian interpretation is that the frequentist estimate of probability is only based off of their observation. So if they have to pick a side, they will only pick the side they have observed.
Yeah. Yeah, the frequentist probability is the limit and then approaches infinity, and in that case, n is only 1. So you get the number of times you got heads divided by 1 is 100%.
So when you're saying the Bayesian interpretation, are you actually meaning the kind of the critical interpretation that that Bayes would be saying this is why the frequentist approach leads you down a path that you don't want to go?
Yeah, that's what I kind of got out of it. The question I was answering is what would the critical Bayesian say about the frequentist answer?
Yes.
Why he would say it's wrong.
Yes.
What was the Bayesian interpretation of frequentist C's?
Okay, good. Thank you. Eric, you're up.
Hey, what's up?
Hey.
Which one do you want me to do?
Your pick.
I can do the top one since that's already up. So for that one, when they talked about Venn diagrams, I'd never seen a Venn diagram that was actually a square. So again, as the undergrad mindset, I want something easy. I tried to basically say, hey, here's a circle Venn diagram that everybody sort of gets and understands. And if we know these probabilities of the events that could happen, can you draw this in a square, which would be, compared to what we read in Shaw, and use that, because I really thought that the square one that Shaw gave was a lot easier to interpret. And so it was just kind of I don't want to say it was a gimme, but it was something to where you could see, okay, here's the similarities between these two types of diagrams. And so that was just the simple approach I took for that.
So I'm curious, Eric, if you will, can you do like what we've been doing before here? Take this question that you've posed and answered, and come up with an extension or a derivative or a related type of question and toss it to somebody else in the room to discuss with you.
I could come up with an easy one. As far as one that's more in depth, trying to think of what the difference between the frequency and the Bayesian approach with this one, as far as like, you can come up with something and say, hey, what's the probability that something with the what the item A, whatever that stands for, like, what would the probability that if we pick randomly just one of them, that it would be A? And so that's more like the frequency approach, I think. I'm thinking about how Doug talked about, like, say if we picked one item that was just like, say, A and B, and we asked him to, if we ask someone else to say, okay, if we pick another random item, what's the probability that we'll see A? If we're looking at the Bayesian approach, like he talked about, every single time we should get A. I'm not really good at asking questions, so I'll be welcome to, if there's a lifeline on this, like phone a friend, I would be grateful for that.
So let me offer you a little nudge from the side, which is you don't have to ask a question. You could just discuss some aspect of what you're offering, because so maybe try to figure out who you want to talk with in the room and ask them to, well, what's your take on this, right? That's a really short, open-ended question.
Yeah, thank you for that. I will now make my final answer. Tommy, if you have a microphone, can you discuss what the advantages and disadvantages of the two types of diagrams, whether it's a circle or the square?
I'd love to. The circular one requires 3 quick motions of the hand. The square requires 4 with 3 hashes vertically and 3 hashes horizontally, so that requires extra penmanship. Other than that, I like to see the overlap of the circles. It seems to make more sense to me directly, but the thing about the square kind of confuses me. I feel like possibility of A and B happening, B and C happening, A and C happening should be more than A and B and C all happening. So is there something there that I'm missing?
I actually gave like the statistics of each one, so it's probably not to scale, so that may be confusing to you.
That would be easy. Can I further expand your question?
Mm-hmm. Yeah, keep going. Because, yeah.
I mean, shall I?
Well, let Doug jump in real quick. So The problem with the square method is proportionality. If you have something to where they're not equal, like AC and BC weren't equal, this very quickly becomes a 200 by 200 matrix because each square has to be equal.
So it's like a
Proportional.
Yeah.
Yeah, that's
Right.
Go ahead.
Sorry.
Go ahead.
I was, because the one in the book, it's a 3 by 3 square. And so I was trying to come up with something different and other than like a 2 by 2. And yeah, that was one thing. I was pretty careful. I had to pick my stats right just so that I would have this really nice, clean, 4 by 4. So yeah, that's a good point.
I have concluded.
Say again?
I have concluded.
Okay. What I liked, Eric, what I liked about what you did was because I liked that you took something that you found challenging, this idea of you hadn't seen, again, kind of the grid called as a Venn diagram. I'm with you. If someone were just to say Venn diagram to me, I would start drawing circular motions. And so, Tommy, I liked that you brought it down to numbers of hand gestures required. Eric, as you decided to kind of go to a 4 by 4 rather than a 5 by 5 or a 6 by 6, help me understand why you said that the text had offered a 3 by 3 grid to represent 9 elementary elements or events. So why did you go to a 4 by 4?
It was pretty much the same reason as Tommy, because if I did 5 by 5, I would have to add text. I used SolidWorks to make that, and that was fun enough. And so I thought 4 by 4 would be adequate. And with the undergraduate mindset, if this was a quiz, I wouldn't want to do more. So
Okay.
yeah, it's pretty simple, really.
Hey, this is Kevin. Can I make a comment on this? Just an observation. So I was with Eric as well. I had to look up Venn diagrams.
Yep.
Why is it circles? Why is this squares? But in retrospect, looking at what everybody's discussing, if you were going to do maybe like a MATLAB program or something, and you were going to try to create matrices that maybe indexed all these things, I could see the circles kind of being useless and then the squares being useful, where you can, even if you're going to have a gigantic, number of squares in your matrix, you can always do the trick where you go, x1, x2, x3, ... xm in one direction, and so it can help you lay it out mentally for programming later. Is the point?
Mm-hmm.
Yeah, it's just meant to be a visual tool, not an actual decision-making tool.
Matrix format.
Yeah. But it's more useful visual tool if it's not circles, because I don't, you can't see that otherwise.
Yeah, so as I move my mouse, do y'all see an arrow on the screen? I was always curious about that.
Yes.
Okay. So if we were trying to, Eric, the mind of an undergraduate is often very legalistic, and so there might have been a stall point. For instance, I mean, the amount of overlap on the circles being representative of like percentage of the likelihood or this. Would you agree that perhaps we need to overlap these less? If someone were going to say to you that the kind of the geometric area, which very quickly you can see when you're looking at 1/16 of a block square size representing 1/16 of the total area, then is this central part of your overlap working?
Yeah, I would agree it's not to scale. I spent a whole lot of time drawing those circles, so.
Could it ever be
I
to
was
scale though?
very
Because
laborious. But really, it's like Bob Ross. It was just a happy little accident. So.
Yeah. I like that you didn't just pull one from, a graphic from elsewhere. But what I'm offering is, I really like what you're doing with this question. And I think, Doug, you were starting to allude to it when you offered your discussion. So, Doug, I want to hear you talk a little bit more about what you were saying. Or Kevin. Or Tom.
what's that? So
So
I have a comment too. So with the squares, you can achieve equal probability for the AB, AC, BC, and ABC areas.
Yep.
But because they're defined as 6.25 each.
Right.
But I'm leaning towards it's impossible to draw 3 circles where the 4 center overlapping areas are all equal in size.
Mm-hmm.
So it's, it looks like only certain cases you could actually draw it where they would be proportional.
Yeah. So, Eric, I'm thinking that if I was going to borrow this and credit you with, kind of coming up with a way of thinking to help people kind of move from traditionally what they've thought about Venn diagrams to here's a different way to think about it, is to just put a quick, not drawn to scale sort of qualifier on the top answer. Because I could see the concrete thinkers especially in a kind of a new learning environment would try to find that they would try to find the importance in the way that you actually drew the original Venn diagram and try to build from that. So in some ways, I'm guessing what I might be, let's see, because you said a 6 1/4 probability of any combination. Okay, so it's not that A and B and A and C and B and C. So it's not this space. Okay. I think I didn't actually read your question right when you first did it. I thought you were only claiming 6.25 for the combined, all 3, A, B, and C, which is that one.
Right. No, it was a 6.25 for any.
For any of the combinations.
AC, BC, or any of them. Yeah.
Yeah. Okay.
Yeah, I relinquish all copyright, patent, whatever. You do not have to credit me for this question. I don't want any undergrads coming after me. That would not be good.
Okay. Kevin, what did you find when you started looking for Venn diagram descriptions?
So I found circles.
So, and Kevin doesn't want to admit, but there's also voxels. So there's also the 3-dimensional cubes, and we use them for really large combination sets.
Ah.
Or I'll raise you one, and instead of circles, let's do spheres in 3D.
There we go. Is that so? Spheres instead of cubes? Yep.
See cubes a lot. So.
Yeah. Do you think engineers like cubes better than circles or spheres?
Absolutely.
Yeah.
Whenever you're doing computational, you have to assign a matrix location to it. So it's a storage and a retrieval point. So I think naturally we gravitate towards things that meet our math nomenclature.
Mm-hmm. Yeah, because we don't really think radially and two angles in a spherical coordinate system for matrices. We could, but we don't. Spherical matrices. Okay, I'm digressing. We're gonna pull it back. All right. Thank you, Eric. Well done. Ethan, you're up. You can pick your question.
All right. Mine were all pretty simple. I was just kind of trying to use things that I understood
Yeah.
about all this stuff. So I'll just go with the first one.
Okay.
If elementary events A and B are disjoint, what can you say about the probabilities? I have 4 options there, and if they're disjoint, that means that the probability of A given B equals 0, because that means if A occurred, then B definitely did not occur. And also, I also have the note that the inverse or the opposite is true. Probability of B given A is also 0. So, I don't know.
Okay. All right. It's your turn to now. Do you want to try to connect your question to anything we've previously discussed, or do you want to extend it? Do you want to discuss it?
Yeah, I'll extend it. I'm afraid of throwing someone under the bus though, because.
Well, you're not. We're all in this together, so you're just going to.
All right. So I'll leave this open to anybody who wants to answer it. But D, probability of A given B equals probability of A, corresponds to another type of something else you can say about the two events, which is what term?
Was that intersection?
Oh, yeah, Drew got it in the chat window. It means they're independent.
Ah.
One's not dependent on the probability of the other. Good job, Drew.
Well done. So in a sophisticated multiple choice space, that would be justify the one that you know, the way that you ask it. Here's 4 choices. Here's the straightforward answer. You actually, even in your answer, you elaborated. But then as a questioning tool, one could then say, discuss what these other solution or the other answers are, and if they have no meaning, or if they do have meaning, just like what you did. So that was good. That was a good extension. Nicely done. All right. Jason's not with us, so we can't pull on him. Kevin?
I'm here.
All right. Which one of these do you want to play with?
Let's see here.
You can present to us, and then
We'll do number 2.
okay.
In case there's any Ford fans in the audience. Are there any Ford fans in the audience?
I have driven a Ford multiple times.
Call yourself a Ford fan, and also I can't call on you, so. Okay, so I'll read the question. Better Business Bureau data shows that 5% of Ford vehicles are lemons, 20% of Ford vehicles are made on Fridays. So the probability of B is 0.2. Among all the Ford lemons, 40% were made on Fridays. Using the statements of Bayes' theorem below, what is the probability that if your Ford was made on a Friday, that is a lemon? And so really this just ends up being identifying what PA and PB is. And actually I left PB in this problem statement. I meant to take that out. PB equals 0.2. I meant to just say 20% as a verbal statement. But you know, it's identifying PA, PB, and then the probability of B given A. So Better Business Bureau data shows that 5% of the Fords are lemons, so that's PA is 0.05. 20% of Fords are made on Friday, so that's PB equals 0.2. And then among all the Ford's lemons, the vast number of Ford lemons, 40% were made on a Friday. So that means that the probability of B given A is 0.4, because that's the probability that they were made on a Friday, given that they are a lemon. So Bayes' theorem, it's a plug and chug then, and then you can see the math there, but it ends up being 10%.
Yeah, that's good. So Ford only works Monday through Friday?
Well, they should only work Monday through Friday.
Ford stands for repaired daily.
First on race day.
So how would you like to play with this and toss it to somebody?
So when you say play with it, like change it, or?
It's totally up to you.
Okay.
If your car was made on Wednesday, what's that?
All right, I like that. Doug had a good suggestion. Can I use his suggestion?
Yeah, you're in control.
Okay, so the question for the poor soul that gets asked this is, if your car was made on a Tuesday, what's the probability of your car being a lemon?
Ah.
And I will ask my good buddy Jason if he's on the line. Is he not?
No, unfortunately, he's out today.
All right, well, I will ask my second good buddy, Mr. Vanderlei, because he's got to type it out. And this sounds like a long answer.
So the restatement of your question is, since you did, I was going to say any one of you could go back into your posts and elaborate. You know, you could share your extension. So just for clarity, Kevin, because I mean, this is a good one for us all to play with. So will you type in your extension on number 2?
Okay. Like right now, or?
Yeah, if you can.
All right, hold on.
Meanwhile, Scott has answered. And Drew is questioning.
So I guess you have to make the assumption that out of all the other days, there equal amount of cars are made, or something to that effect.
Yeah, you have to assume all the other days are equal.
Yeah. I think Drew said something about not Friday, which is kind of the same thing. You divide your not Friday by the other days.
And I wouldn't wait on me typing it in. That's possible. I'm still trying to get to the sign-in page. It's a little.
Oh yeah, no, you're fine, because I think discussion is running already, because we have it verbally. Drew's added another query. So I'm just trying to remember what your question was. So the way you had it worded, you said, using the statement of Bayes' theorem below, what's the probability that if your Ford was made on a Friday, that it is a lemon?
Right.
That comes out to 10%. And so you're now asking if your Ford was made on a Tuesday.
If all you have is the information given, what is your best approximation for the probability that your Ford is a lemon?
If it was made on a Tuesday.
If it was made on Tuesday. And during the exam, I would be sending Drew back to his chair and telling him he does have enough information.
Basically, it's not Friday divided by 4.
Good job, Scott. I think he got it.
That's 1%.
So you do have to assume that they make the same number of cars each day, I guess.
This is the plant show.
It was lightning. We're good.
Yeah, that was the weatherman.
Yeah.
So I think, no, it's not a lockdown. So I think that the logic there was the statement among all the Ford lemons, 40% were made on Friday. So that means 60% of the lemons were made on Monday through Thursday, right?
Mm-hmm. All right. So are we done with this one?
Yeah, we're done. Our final answer is 3.75%.
All right. So Kevin, what do you drive? Do you drive a Ford?
I drive a Honda.
Okay.
I would drive a Ford. I love getting car guys riled up, so. I went to school near the Charlotte Motor Speedway, so did Matt, so.
All right. And yes, Drew, we were assuming things all over the place. Matt.
Yep. So the number 1 and number 2 are pretty much gimmies. The draw a Venn diagram of the different probabilities. And then 2 is explain the difference between frequentist and Bayesian. The number 3, which is a true-false. So between frequentist and Bayesian approaches, one is right and the other is wrong. So I think, what I'm trying to get at here is that everyone seems very stuck in their opinion of I'm right, you're wrong, I'm Bayesian, you're frequentist, I'm better than you. And in reality, they both have their places and uses.
Both wrong.
Yeah.
All right, so giving you equal opportunity to take something of what you've got here and extend, reorganize, play with.
I'm not really sure where we go with that. It just, you know, everyone seems, you know, even the book, you can see the bias of, you know, one school of thought versus the other, and even the comic was kind of trashing the frequentist approach pretty heavily by taking, you know, an event that's obviously not happening with the sun blowing up and saying that it happened. But, you know, in reality, both approaches have their uses.
So as I'm thinking through and kind of listening to discussion today, I'm reminded of, I've started reading a book that I haven't gotten very far in it, but I've talked about it with some other folks, called The Righteous Mind. Are any of you familiar with that one? It's not an engineering, it's not a,
None of us here have.
So Drew, what are you offering to share?
I can tell you that I've read it. Yeah, I really like it. I remember that's one of the books, like when you get to start talking to people, that it's good to share with people. I think, like, what's its subtitle? The, like, how good people can disagree about, you know, things.
Yeah.
Yeah. And his, of course, in it, he's very particular about, you know, he lays out all his research he's done about different value systems, and that's what a lot of it's tied down to. But I think it works for other things too, like in here in this context, where anytime you get into some of the more subjective things, like Bayes sometimes gets, you know, called out, and a lot of the statistics might get more subjective about how, you know, you can come from like we were just saying about, there are two different ways, frequentist and Bayesian, and neither one of them is technically right. You can have the same sort of thing with that. You could sort of draw a parallel where, you know, from their point of view, and given what they value and what they don't, of course they like the one that they do, but you can have a completely reasonable stance based on what your values are and what you think is important that comes out somewhere else. Because maybe you're a frequentist, and that's what you think it's really important to do X.
Yeah.
Dr. Pardue, that kind of was brought it up to your...
Yeah, Drew, I think that, of course, you've spent, yeah, that's exactly what I was feeling a connection to what's the knowledge that we pull into play in terms of prior knowledge that would inform our a Bayesian way, or if we're a frequentist and we want to say that, you know, this is really the best way to look at it, what are we leaving on the table? You know, what are we purposely saying that has no impact on this particular, in order for us to be objective and formal, we're going to set aside these, you know, subjective concepts. But that actually allows, I mean, in doing that, you have to say, what do we value, and why do we value it, and what might we consider to be valuable information. So the book goes, I mean, I highly encourage, actually, most people to read it. I'm glad that you have multiple copies, Drew, that you can share. I've got my one electronic copy, but I think it's a book that I'm liking well enough that I want to kind of be able to hand it off and ask other people to read it and say, what do you think? Because in the realm of trying to help others through, as engineers, we often have to kind of guide other people through our rationale. and we're making decisions about how much of the in order to see the forest, how much of the weeds we're going to or how many of the leaves on the forest floor we're going to ignore, and or say that we value this particular information over that particular information, and we want to say, that we could help others by understanding first why they may not think certain information is important. So I think that the righteous mind kind of helps me understand that my way of looking at things and everything that I've experienced as a kind of an analytical mindset to this point in time means that I look at the world very differently than other people do. Doesn't mean that it's any better or worse. It's just that I tend to value certain kinds of information differently than they do. And that author is so much more articulate than me that he does a better job explaining all of that. He's remind me, Drew, is he a social psychologist?
Yeah, and I think that's where he really started, and that's why a lot of it, he boils it down to values, and he's done a lot of research on different sets of values and how things like fairness or something actually breaks down into but there's kind of different definitions of what's fair, whether it's the quality of like outcome or quality of, what goes into it. He's really good at explaining it, and he's even got a couple of websites where you can go and take his little quizzes and it'll rank you down, which is probably going down too far in the rabbit hole of his side, but he's definitely coming to it from the social side. But it definitely reflects really well, and I've noticed in my own part, and even some of the training we have here at ORNL, where they try to get you to have conversations with people and trying to understand where the other person's coming from, right? That the person may not even be aware, that they're making these different value judgments, and that's how they've really decided that they're right about something, or that you're wrong about something.
Well, and that was
and it may be hanging on something, a disagreement and what's important, or what it really means for something to be right,
right,
that sort of thing.
Well, and I think one of the early points he makes early on, and I think that's what kind of got me thinking about why I tend to be more comfortable. The more I'm learning about Bayes' way of looking at probability, I'm beginning to be like, well, yeah, okay, why don't we teach that first now instead of just the frequentist approach? But that means that I'm intuitively kind of drawn to something, and now I'm trying to learn more about it, to formalize my understanding of it. So in a way, he actually talks about humans and the way that we make our meaning in the world, that many times we've made an intuitive decision, and then we go back and we start justifying it with logical, definition-driven, terminology, value-based ways of expressing how we can get someone else to think the same way that we do. So we go into kind of a mode of, in order to convince other people to make the same decision that we would, then we begin to formalize it. So it just kind of opened up. I reading in these two areas this summer I see some overlap. I see a Venn diagram in my head, and it's in no way cubic. So I was just kind of curious if anybody else had read in that way. Took us down another bird path, or anyway. Thanks, Drew. We'll talk more about that later. Scott, I wish we could put you on, we just don't have you verbally. We have you text-wise. So I'm not sure if I can give you equal or fair representation in the Zoom room, but I'm going to pop your questions up. And if you want to, I want you to have equal opportunity to toss the question to someone. We can see all your questions. So in the chat window, can you designate who you want to direct your question to and what you would ask them? Scott, can you type something in the chat window to let me know that you heard me? Did we lose Scott? I've waited my requisite 60 seconds, so. Drew, did I drive everybody away with my taking us into a not numbers space?
I'm not sure. Maybe so. Maybe they're all deep in contemplation at this point. So can I ask one on 3? So he's saying here that, you know, P of x theta is the likelihood function of theta. Just make sure I understand that, because before, like when it was P of A and B, you know, it was the probability of A given B. So here it's the probability that your x values that you're shoving in at the first place is actually a fit to the mean and standard deviation that are your theta values. Am I understanding that right?
So this is page 166 from the text, right?
Well, yeah, that's where he's talking about. That's where they call it the likelihood function.
But it's the probability density functions.
Yeah, but I guess I was really talking more about 9.2, where he starts actually using numbers, where x is the kind of the values that you've got and your error, and then theta is your mean and your standard deviation. I guess I was just trying to understand it, make sure I understand it at least of what that really is. Because I wasn't sure I completely had it.
Oh, I see. Yeah.
So what I thought maybe that meant is that it was kind of it's kind of the likelihood that your values that you fed into it, your x1 through n, you know, or your starting points and your error, that they would fall out for a distribution that had that mean and standard deviation. But I think I may be reading too much into it. I don't know if this was I could get a Dougal answer or not on this one.
Doug, are you in the room?
I am. I've just been arguing with Kevin, so what's the question?
Well,
Everyone's working on his own problem for the last few minutes.
Oh, okay. All right.
Understand the shortcut?
So
like equation 9.34, Doug, what am I really getting at? What is this likelihood function? Can you give me explain it like I'm 5 version of what this really is?
I keep wanting to pre-give away what we're going to do on Thursday, but this is assuming that I'm going to have a normal distribution, and so just the regular bell curve, I'm going to go ahead and I have to know what my standard deviation is. But basically, it's just playing with the normal distribution to give you the coincidence set. So right now, X bar and theta bar are different sides of the same curve, but it's going ahead and applying the Gaussian equation. So anytime you see this pi with the 1 over 2 pi to the half power with a sigma in the bottom, it's a Gaussian distribution function. Basically, it allows the base to spread out to match your data set. No? Crickets?
So if I'm understanding that right, and you can help me here, like, so that's it's kind of telling you almost like where you're at or how much overlap you have between the data set that you shoved in and the mean and the standard deviation that you shoved in, like how good of a match you've got, kind of?
Yeah, so the way that X bar and the theta vectors are supposed to work, they have to split at the peak of that curve. X has to be the left half and theta has to be the right half. So what it's telling you is how well you found the maxima, the peak. So if it's perfectly symmetrical, then you don't need the beta and you don't need mu. If it's asymmetric, you adjust it with beta and mu.
Well, you found the peak. Okay, so like how close you are to the hump in the probability curve?
If you go to page 169 and you look at figure 9.2, see how the top one is perfect. It's equal on the left, equal on the right. So mu is basically 10. But if you look at figure 9.3, theta, which is your standard deviation, is sort of skewed asymmetric.
Okay.
Both of them, X bar is the left side of the peak and theta bar is the right side of the peak.
See, I guess that's the part I don't know what you mean. Because they're saying like X bar is, I thought they were saying X bar, you're feeding in all these.
So go back to page 164, equation 920 and 921. You see X bar is X1, X2 up through Xj.
Right.
J is the peak, and theta bar is Xj plus 1, Xj plus 2, all the way till the end length L.
So are you saying I couldn't have like 10 variables going in and X and only those two values of mu and sigma for theta? They've got to be equal length?
They don't have to be equal lengths, but X vector and theta vector are just subsets of L random variables. So you can't, if you just throw out to just mu and theta, you've killed it because theta is just Xj to XL.
Okay. So that's not where you get to those marginal, well, I guess that's what they mean by the marginal PDFs down there. They're trying to...
Yeah, they're trying to do the
integrate
two halves and trying to do it with a Gaussian equation. And that's why you end up with the H of theta.
So it's like a symmetry problem.
Yeah.
Yeah. Yeah.
All Gaussian is normally trying to do it symmetrical based off of peak, and so you're trying to distribute between your two functions. So when I'm doing atmospheric dispersion, I usually have a Gaussian distribution in the X coordinate, a Gaussian distribution in the Y coordinate, or Z, depending on what my reference frame is. And you're trying to figure out the distribution, cumulative distribution down the third axis. Your marginal PDFs are 937 and 938. On Thursday, we're going to walk through an example that's 9-dimensional.
Ooh, a little foreshadowing. Nice.
I just pointed out to Doug, we'll be like skipping off the top of it rather than walking.
Kevin keeps crying too much math and cuts them off.
We'd have an entire another semester on just that one case study.
Oh, yeah, yeah.
It was a good case
Well,
study.
That's good.
So you guys might be thinking it's really nice that Kevin has a partner like Doug and how easy it is. It's kind of like being tied to the bumper of a car.
That forces Doug to slow down so it doesn't kill you, it doesn't kill everyone else.
But if he comes to too abrupt of a stop.
Scott's back.
Well, I didn't mean to change screens. Sorry about that. So, Tommy, did I give you a chance to?
I have not completed.
You have the floor. You can pretty much ask whatever of whoever you want. It would be helpful if you would kind of tie it to something that we've already talked about today. So you're working on your questions. They'll get posted, but at this point, it's almost like you're the wild card. So what would you like to ask, and who would you like to ask it of? Got to take yourself off of mute.
So I'm smiling, but I don't have anything to say. But I like the power.
Yeah, you got the wild card. Go. Of course, giving you the wild card could just put us all out of our misery too.
So, Ethan, because you didn't want to put anybody on the spot, I'm going to do so for you. How do you see using either of these two methods to do your safety analysis stuff in the future? Can you make use of this?
Yeah, actually, I think that's kind of a problem that we've had, is that we have such little experience with the types of issues that we're analyzing, that just using the regular probability approaches that I would normally think about using don't work, because you have no you can't just assume it's never going to happen, I guess. You know what I mean?
Yeah.
So
it's not a good thing.
So I think using some priors and some maybe combination could actually be useful as far as determining whether these things are actually possible things to worry about, I guess.
Right.
I'm trying to be very vague here.
Yeah.
But I understand the question, and I think it is something that we can use in the future.
Cool.
So Ethan, are you working on your? Remind me, are you working on your master's?
No, I'm one of the PhD students.
Okay. Yeah, and I'm sorry, I just don't have my grid in front of me. So who are you working with? What are you doing?
Oh, I forgot the name of my advisor.
Oh dear.
It's been a few months since we talked. but I'm doing nonlinear dynamics of centrifuges.
Okay.
But what
Is it Anton?
Is it?
what's that?
You said nonlinear dynamics of centrifuges.
Is it Dr. Anton?
No.
Is it Dr. Tui?
Dr. Chen.
Oh, Ping Yan Chen. Okay. Yep.
Yeah, that's
Okay.
right. Yeah. But yeah, what Tommy's talking about is I do like safety analysis, and some of the I have to use basically worst case scenarios because we don't really know what the likelihood of certain types of failures is, because
Right.
you know, and so using these statistical methods that we haven't actually used before could help in terms of not having to really over engineer everything that we make.
Right. Right. So I wondered if you had, if I don't know how much freedom of workspace and time, how many projects are on your plate and you have to answer, how many bosses you have to answer to. But I didn't know if you would, I was trying to figure out if there was a way for you to maybe explore that as a part of your dissertation work. If you could kind of like do your own kind of example case study. Is your dissertation work related, or are you just kind of exploring it because that's something that you wanted to do? Is it related to
right now, my dissertation is extremely super broad. So it could be related to almost anything that this project that would help this project. So it could be, in theory.
Yeah, I just wondered if you could figure out a way to kind of explore what you're talking about trying some alternative or developing a series of analysis statements that would allow you to kind of compare and contrast the approaches.
Yeah, it's definitely something for me to think about, because I think that would that has possibility of helping a lot.
Who's on your committee?
Let me see if I can find my my POS.
That's a terrible question for me to ask, since sorry.
My POS has changed a few times.
Okay.
Let me see. All right, the most recent one. Well, it's signed, but I can't read the signatures.
Yeah, and that we used to have to print our name. I don't know why they took the print or typed name and then signature off of that.
It looks like one of them is Dr. Wilson.
Dale or Chris?
Dale.
Oh, okay.
Yeah, I can't read the other ones. Wow, those are fancy signatures. I can't say anything because mine looks terrible too.
Yeah, well, I'm just kind of following a thought.
Oh, here it's written. It's written on the next page.
There
I
you
got Dr. Chewy, Steve Canfield, Dale Wilson, and Dr. Radman.
Yeah, he's
Not
in
you?
electrical and computer engineering. Yep.
And then Dr. Chen is the chair.
Okay, that's a good committee. Yeah, Rodman teaches the random stochastic variables course for the ECE. So are you done with your courses now too?
Yep, this is my last one.
Okay.
Unless I decide to take some more.
Yeah, well, you know, we're never done. Thanks. One of the things that kind of crossed my mind, and I would hope that someone here, having spent some time with you all this summer, it's in my mind that we need to, and Dr. Languri alluded to this, our discussion last week, that it would be beneficial to kind of understand from a systems level perspective where each of you are as a cohort, with the idea that 5 years from now, how is cohort defined differently for our ORNL, Tennessee Tech partnership? And so I'm concerned that, that we have on paper that somebody, and the reason why I'm talking to you all about this right now is that when I started asking questions once I met and got connected up with Drew, and I kind of started thinking, well, not just Drew, but, there's this whole crew of you there. Is everyone feeling well connected in the sense that you're there and we're here? Who's the point person at Tennessee Tech that you all reach out to if you have questions? Is it somebody in the College of Engineering? Because this is not just meant to be a singular department sort of issue. And so it seemed like it took me a little while to kind of figure out that may not be a name that you have. Do you all feel like you have a name of somebody that you can reach out to if there are questions regarding cohort issues? Yeah. So I'm hearing back I'm watching the chat window. So Scott's saying, yes, there are several departments doing similar programs. ComSci, EE, yep. Drew says, no, there's not one in particular. So Clay, you're right. You always start with your advisor. And then, yes, there is a department chair in the question of if you know what department you're attached to. But again, because it is a college level partnership, without rocking the boat too much, I'm just going to let you guys know that I am going to kind of go to the college leadership. We have a new dean, and kind of express my concern for the level of not lack of, but formal recognition that there needs to be a point person not because if you don't have an advisor, how do you know how to get started? Yes, you can do your department chair, but that department chair has lots of different issues on their plate at any given time. So to me, there needs to be a cohort liaison. Anyway.
Holly. Who's the new dean?
His name is Dr. Joseph Slater, Slater, and he comes to us from Wright State. I think that they may have put something online. They may have done like a little
blurb, I think, somewhere.
Yeah, it might have been in Tech Times.
I think that would be a great rotating position for whoever is visiting ORNL that year.
Mm-hmm.
Since they're coming out here anyway.
That's true.
I never knew.
That's a good suggestion. I know that Dr. Languri was there this summer. I don't know who else from the College of Engineering is there, but that usually is known well enough in advance. Doug, that's not a bad idea.
I don't know how this is going to work. I know with ORNL and other places, a lot of times once you finish your PhD and you're working full-time, they sometimes put you on an emeritus faculty list. I don't know, it happens different ways with all the different schools, but this may be something that, it'll be to someone in the cohort, once we finish the program, to be that liaison for people here, starting out to whoever it's gonna be, but they're still Montevalli, so.
Well, if they were officially working with the company, or an LNY12, there would be someone in HR development.
So,
Is usually a student.
a former student, yeah.
Yeah, they don't have a picture of Joe up there yet. Yeah, I'm just a little concerned for y'all. Not you specifically in, but again, kind of more at that continuing good partnership, shall we say, so that, Doug, if just like you're talking about, you guys are really kind of that feet on the ground advocacy for a mechanism that other people can pursue advanced degrees, and when possible, if it makes sense to do that in partnership with Tennessee Tech, then here's your starting point. Here's a person you can talk to, and then from there they can help do the subsequent navigation. It's like that pre-advisor kind of status, that you've got, because you've got to navigate some course selection. Like right now, if we started somebody, this fall, then what's their real starting point? It's very different than if it's a graduate student here at the university, having the freedom to kind of choose their coursework. It's like, how often are we going to start a cohort? Is it expected that you've got to get 5 to go, or can we kind of do a rolling start? I just think there's some interesting questions to explore there. Drew, thanks for finding, I think you found there he is. Yep. There's Dr. Slater. Okay. I will be there in person. So who is in charge on TTU's end? Right, Scott, that's what I'm trying to find out. I would say nominally it should be Dr. Montevalli. And it just may be one of 10 projects that he's working on. So I would like to confirm that, but I do think there should be a point person in the College of Engineering's office. Again, because ultimately, if PhD is your intent, whether or not master's is enough, regardless, he does everything research oriented in the college. And again, our PhDs are held at the college level, whereas masters are earned in the disciplines. So I will see if I can find an answer to that by Thursday, because I think it's important, especially in light of kind of the general nature of discussion that we had regarding, and thank you again for being really honest and open with Dr. Languri as to your feedback around the, and the questions you asked around the comprehensives or qualifiers / comprehensive process for the PhD. So I'll be there on Thursday. And Tommy, are we in the conference room that we were in for the other times that I was up there?
Yes, should be 5800 0304.
Okay. Is it okay if I bring food?
Well, yes.
Okay. I didn't know if they had a food restraint on certain rooms or something like that. So I think the general plan, other than it will be donuts, and I think I have a general understanding of who likes what in terms of that, but I also may bring a couple of options that are, on the healthier spectrum, some fruit or something like that. But we will convene. You all are responsible for your own drinks. but I'll bring some foodstuffs.
Well, thank you.
And is anybody averse to chocolate chip cookies? No peanuts, right? We're not gonna, no peanut butter cookies. So I can't rebuild the example out of the visual base, but I could do chocolate chip cookies and some other kind of cookie. Oatmeal. You could do chocolate chip and oatmeal. So I'd rather bring cookies than donuts because that's just easier for me. So Scott's okay on CCCs. Clay, you okay with cookies?
Absolutely.
Kevin, you'll be okay with cookies as long as they're not peanuts?
I want Bayesian cookies, Bayesian. Peanuts instead of peanut butter, Bayesian cookies.
We need a PDF of the amount of chocolate chips per cookie.
We could do oatmeal cookies and oatmeal with raisin and oatmeal with chocolate chip and oatmeal with chocolate chip and raisin. And we could put them in various boxes. We could rebuild the Venn diagram that Eric, that you created. All right, so it's going to be cookies instead of donuts.
Scott was the one bringing the donuts. You were bringing cookies.
Oh, that's right. You can decide to put the thumb screws to Scott for Scott. Did you remember that you were supposed to bring donuts? I didn't want to put you on the spot, but I did put you on the spot when you weren't there one day. We volunteered you to bring donuts. No, there will be two kinds of cookies. I was just free thinking there. Ah, thank you, Drew. I will read the paper. All right, so we definitely have food. Y'all are responsible for your own drinks. I will see you on Thursday. Looking forward to the presentations. Please make sure you try to get them posted by sometime Wednesday so that they're all available. And where you will be posting them to, I think I've gone ahead and made should be under the assignments. Yep, the case study too. So just post it to there. And I will see you on Thursday.
See you later.
All right, bye.